Hey AP Stat students, today is going to be a long day. I may break this video up into 2 videos just to kind of give you a little breath. But if I don't, make sure you pause and take breaks where you need, okay? So by the end of this video, you should know the difference between a discrete versus a continuous variable. You should know how to plot quantitative variables, and you should know how to describe and compare distributions. All right, let's start with discrete versus continuous variables. These are 2 types of quantitative variables. I'm going to put those definitions up here in a second, but I want you just to think about it. A discrete variable would be how many goals my son scored in a game, or how many goals a team got each game throughout the year, okay? A discrete variable would be how many children are in your family. A continuous variable would be the time it takes for you to run the mile or the 100-yard dash. A continuous variable could be the weight of your dog, okay? Can you tell the difference? Think about it for a second. Do you know? All right, let's learn. Representing quantitative variables with graphs. Well, first, we have to know the 2 different kinds of quantitative variables. A discrete variable can take on a countable number of values. So, number of kids in a family or touchdowns scored. Now again, remember, pause where you need to, okay? I'm gonna go fast because I'm not walking around the classroom waiting for all of you to write things down. That's the beauty of the video. A continuous variable can take on infinitely many values. No matter how small the interval between the 2 values of a continuous variable, it is also always possible to determine another value between them. Excuse me, I can read. So the time it takes a 100-yard dash. Those of you who run track, you know there's a big difference between a 100th of a second or even a 1,000th of a second, okay? Time, continuous variable, infinitely many values between 2 different values, between 10 seconds and 11 seconds, okay? Hopefully this slide you have the difference between a discrete variable and a continuous variable. Let's keep cruising. Okay, now we need to know how to represent quantitative variables with graphs. And never dismiss the power of a dot plot. You will be having a graph throughout the year, and a dot plot is a really nice, quick way to represent a quantitative variable. So what I have here is I have created a dot plot that displays the distribution of the number of turnovers in the Oakland Raiders 16 regular season games in 2009. So I have the data right there. And then, like I normally teach, I've talked about this with you guys before at the beginning of the class. I like to use the whole line down the center when I'm teaching something. So I have steps or definitions over here on the right, and then I have the actual work on the left. And those of you who have had me before in Algebra 2 know that's how I work, okay? So step 1, whenever you're graphing, you wanna just look at the minimum and the maximum of your data so you know how to scale your data. Because although I went by ones here because my minimum was 0 and my maximum was 4, let's say our minimum was 0 and our maximum was 400. We don't necessarily want to go by ones then, right? We want to go by 100s or whatever it may be, okay? So with that min and the max, you decide your scale, you mark it out. We went by 1, 0, 1, 2, 3, 4. I would get in trouble with the College Board because I don't have a label here. So I would want to put the number, whoops, not the dollars, number of turnovers in the Raiders 16 regular season games, okay? And then what I do is I put the dots. Now, I am not a fan of a dot. I'm a fan of an X, okay? So I would put an X here because that represents that first 0. Now, I don't go in order. I would start with 3, right? So this 3 went there first. I put an X there, okay? Then next I see a 0, so I put an X there, right? And I just keep going. Oh, I saw another 3. And then another 3. And then a 2. And then a 4. Now, why am I doing this? I want to show you here. And then a 1. Okay, so here's the catch. And then a 2. When you are making a dot plot, see, this is my second observation of a 2, right? I have my first 2 there, and here's my second 2. I have 3 observations of 3. So I have my first 3, my second 3, and my third 3. All of your first observations here in green, those should all be in the same row approximately, so it's not misleading. Now, my second observation should all be in the same row. So I'm on this second 2 right here. So I want it to be in the same row with this second observation, right? Then I have my 3 again. My 1, again, a second observation, so in that row. Hopefully you can catch on to the rest. Just for time, I do want to move on, but that is our dot plot. Don't dismiss the power of it. It's super simple, easy, quick to do, especially when you don't have a lot of data. Okay, the next one is a stem plot. When you were in middle school, you learned it as a stem and leaf plot, okay? Let me cover up the steps here. So I have my data. I have grades on a recent test are as follows, okay? And step 1, when you're making a stem plot, well, before we do it, stem plots are really nice for small data sets as well because you can actually see the numbers versus a histogram, which we'll learn in a minute. So I do like stem plots when there's a small amount of data, although they're not common practice for regular like media outlets. You don't necessarily see a stem plot in like a CNN article or a Fox News article. You would see a histogram, okay? So we have our data here. We're gonna look at our min and our max. So our minimum, I think I already have an order for us, which is nice. Our minimum is 55 and our maximum is 102. Now I'm gonna take my trusty pen, see how well this works again. 55 and 102, okay? There's my min and max. Now what I wanna do from there is I wanna figure out what my stems should be. So that's step 2. And in order to figure out your stems, you wanna cover up the last digit of your min and your max. So you can almost imagine we could cross it off here, right? If I crossed off my last digit, okay? Why did I do that? That's gonna tell us what our stems are. So our stems in this case are gonna go from 5 to 10. And my pen's a little delayed, so forgive me, okay? So from 5 to 10. So what I'm gonna do now is I'm gonna make a stem and leaf plot. And I wanna start with my stems, okay? I'm gonna write them down. I'm going from 5, I'm starting there. 6, 7, 8, 9, and 10. Now, when you are making a stem and leaf plot, I would suggest ordering the numbers first because it's gonna make your life easier. Now that I have my stems up here, the next thing I wanna do are add my leaves. So what are the leaves? So let's see if you can catch on. The first number I have here is 55, right? So I have my stem is 55. Give me a second. Uh-oh. My pen is not working very well. There we go. My leaf then, if you look at the number, the stem here is 55, right? The leaf then is 5, or I'm sorry, the stem is the 5 from the 50, and then the leaf is the 55. So I'm gonna go 55, right? The next one is 56. So I already have the stem being that 50 there, that 5. So I just need to put a 6 for the leaf. Okay, done and done. My next number I see is 72, okay? So I already have the stem of 7. I just need to add the leaf of 2. Done. Now 82 is my next one. I have the stem of 8, okay? Now I just need the leaf of 2, so 82. My next one's 84, okay? So 80, so the stem is 8, that's already there, then 4. So this number here represents 84. Now I want you to notice something. All of my first observations are in a nice column here. All of my second observations should be in a nice column as well. My next number, 89, so I have the stem of 8, I just need to add the leaf of 9. 92. 94, 95, and 96. And then finally 102. I have the stem of 10 already, so I just need the leaf of 2. And there is my stem and leaf plot. Now, some people will say, oh, Miss Opal, There's nothing for the 6. Did I actually have to put the 6 there? Yes, you do, because when we're going to describe, we're going to say, well, we have a gap in the 60s. We don't have any data there, okay? So that's important when we're describing. Let's move on to our next plot. A split stem, okay? Oh no, I gave away spoiler alerts. I have the same data from over here, okay? From before. 55, 56. When I split the stems, the first thing I want you to notice, right, is I have 2 of every stem. 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, so on and so forth. Okay, now the first number we saw, and you can go back to the other slide if you want, or you can just trust me. The first one I saw was 55. So 55 has to go in this second row. Then it was 56. 56 again has to go in that second row. We didn't have anything for the 60s, but our next number was 72. Well, I have 2 7s. I have a top row 7 and a bottom row 7. How do I know which one to go in? 72, I'm going to put in the top row. I'm not going to tell you yet unless you quickly saw the spoiler. The next data that we had number was 82, okay? So 82 goes not in the bottom row, but the top. 84 goes in the top row as well, but 89 has to go in the bottom row. Let's look at the 90s. 92, 94, 95, and 96. The 5 and the 6 had to go in the bottom row. Did I miss? Oh, you guys, I made a mistake. Hopefully you caught that. Just noticed that with my, I forgot this 92. I was going too fast. There were 2 92s, 94, 95, and 96. Forgive me, you guys. I do have it right over here though. So I have that 92, the 92, the 94, but then the 95 has to go in the second row. Oftentimes people have caught on by now. What just happened, okay? The first row, meaning like this first 5, that's reserved for anything, right, that ends in, that is a leaf from 0 to 4. The second row belongs to anything that has a leaf from 5 to 6. And that's for all of them. You can see like 89. Oh, I said 5 to 6, you guys. I'm sorry. 5 to 9. Okay. So the first row, again, is reserved for anything from 0 to 4. The last row is reserved for anything with leaves from 5 to 9. Okay, let's move on, you guys.